Okay, so let's look at these particular questions. We have something like determine the behavior of the following series. We are using P series or comparison test concept. We have four questions. This is the first one, second one, and third one. Okay, so just like the questions are arranged, we will start with this one. Okay, and let's see how we are going to deal with that. So we have the I, which is sigma n from 1 up to infinity 1 over n squared, like this. Okay, so looking at this particular series, what type of convergence test are we going to use? Okay, whether it's converging or diverging or none of them. In other words, the test will fail. Already you should know that we have different types of tests. We have the convergence, which includes the Bertrand, the Rabi's, the ratio. Okay, the ratio, Rabi's, Bertrand, they are the convergence. And then we have the Gauss, and then we also have the Cauchy root test. But here we are going to see if Gauss will work. You know, Gauss is the final place to go if none of the things did not work. None of them failed to work, then you go for Gauss. But here we're going to go straight to see if we can use Gauss to do this. So let's see. We know that by Gauss test, if you can write a n in the form a n plus 1 over a n should equals to n power p plus alpha n power p minus 1 plus plus the lower terms all over n power p plus beta n power p minus 1 plus plus lower terms. Okay, we can write a series like this, and what happened, and if this happens, then we see that if the series an, if the value, if it converges, this one, if the series is equals to this one, the series will only converge. Let's say this one converges if beta minus alpha is greater than 1, and the series will diverge if beta minus alpha is less or equals to 1. So this one, there are only two cases. It doesn't fail. It's either the if you get this, it's either the value taking the limit as it approaches infinity, it's either is greater than 1 or is less than or equals to 1 of them. So one of these cases will happen. So just like you are going to a big hospital and it happens that if that place they couldn't cure it, then that is all for you. So Gauss is like that, the final place to go if nowhere or any place does not work. So now let's see. So we have our an to equals 1 over n squared, and now writing it as an plus 1 over an, this one equals to 1 over n squared, 1 over this one squared divided by 1 over n squared. So an plus 1 is, wherever we get the n, we put n plus 1 there. and the an here is the original 1 over n squared. So manipulating this, we are gonna have n squared all over n squared plus 2n plus 1 like this. Okay. But then we want to write it in this form. We want to write it in the form n power p plus alpha n power p minus 1 plus dot 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 plus the lower terms all over n power p plus beta n power p minus 1 plus dot 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 plus lower terms. And so this will imply that we have n squared all over n squared plus 2n plus 1 being equals to n squared plus 0n plus 0 all over n squared plus 2n plus 1 like this. And so from what we have here, comparing this one here to this, you realize that our alpha is equals to 0 and our beta is equals to 2. Okay, and we are saying that beta minus alpha, if it's less than, if it's greater than, okay, if it's greater than 1, then we are saying that this thing, it does what? It converges. Okay, but if it is less than or equals to 1, it diverges. So this will imply that we have 2 minus 0, which is equals to 2, and this is greater than 1. So this implies that the series n equals to 1 up to infinity of 1 over n squared converges by the Gauss test. And that is all. Thank you for watching. Kindly subscribe.